Hello, my name is Paul Kanyuk. We are back to shading the terrain here. This is the second part of a tutorial. Where we left off earlier, we created some shading for this environment, and we had added some geometry-driven detail, and as soon as we added this PXR dirt node, which computes curvature and occlusion, the render got really slow. So we're going to pick it up by baking that into a texture, making the shading look a little better beyond that once this is baked, and then go on to using that baked texture to grow some grass and vegetation in this environment using XGen. Alright, so let's kick it off by opening it. Pretend you didn't see that. This is where we left off last time. So let's kick off a render just to see how slow is slow. So this is pretty slow. There's always going to be a little bit of a startup cost before you see any pixels. That's not a problem when you're doing live rendering, but the slowness of generating this first pass, and even worse, the slowness of generating, each refinement pass after that, it's really impossible to use the live render feature anymore to do shading, which, isn't the end of the world. That's how people have worked for a long time in the industry, but it's a shame to give it up if you don't have to. Also, for final render, this is just going to be miserable. So that's not great. Look how slow that's crawling. So we want to bake this PXR dirt pattern. So we can do that by creating a PXR baked texture node and wiring that in between the PXR dirt and the mix. Basically, anything before the, all the inputs to the baked node will be baked. So we're going to create a PXR baked texture, connect the result RGB to the input, and then connect that input RGB to the color. Alright, so now the default settings are pretty good. We want file format .text. It's just going to do a regular baking to UV space. The question is, what do we name the file? Now normally, if you're just shading one material per object, you could just, write the material name or the object name or something in the path and you'll be fine. But be careful if this shader is attached to multiple objects or shared by a common layer to multiple objects, which is the case here. Check it out. This PXR baked texture is going to that mix. That mix is going into two different surfaces, surface rock as well as surface ground. So we got to be careful. If we just do a normal file path here, basically we're going to mix the data. The rock and the terrain will conflict. And initially I thought this was a really silly limitation of RenderMan 21's new baking system. But after checking on the forum, turns out there's a way to automatically create a baked texture per object, even if it's just a single material. And that's using this magic syntax where you have open caret identifier colon name close caret right there. That puts the object name in the file path. And this RMan proj is basically just to whatever your project is set to. So let's copy that, paste that in here, and I'm going to just put a unique letter here so I know we're baking something new. And that will do the trick. This is very important because, having a material per object, I don't know who works that way, at least I don't. I like to have as few shaders as possible. So, now before you bake, you need to make sure that all your objects have non-overlapping UVs. Otherwise, multiple parts of an object will bake into the same pixel, and that's bad news. So let's take a look at our ground, open up the UV editor. Damn, that's good. Clearly this was a plane that's just been displaced a little. Very nice non-overlapping UVs. Now let's take a look at the rocks. Oh my goodness, look how bad that is. Every rock is overlapping another rock. That is not going to cut it. We need to go to UV and let's just unwrap that automatic mapping. We have an atlas. Now you wouldn't want to paint in this, but that's not our intention. I told you guys, this is all going to be shading based on the shape of the object, not based on UVs. So this UV is really just to capture the baked texture. We could regenerate that texture if the object changes, not a problem. This is really just an intermediate step. So let's close that and start a bake render. So yeah, you start a bake just by going to RenderMan and clicking bake. And this will be a batch render, so it won't go into it or render view. Rather, your local queue should get a job. It will launch if it's not launched already, and you'll see it bake. And I think this is going to run twice, once for each object. We only have 2 objects in the scene. So while this is baking, I want to allay some concerns. You may have said, hey, Paul, you promised that we're not going to have to UV map our scene, that our shaders will be procedural and go from object to object. Well, when it comes to baking occlusion and curvature, you don't want to ever let that be live. You do want to bake it. But occlusion and curvature is just based on the shape, not on the UVs. So even though it's true, we are generating UVs to bake it in, we're just really doing automatic UV unwrapping. If we add a model, change its shape, we just need to make sure to hit rebake. So we could always regenerate that baked occlusion. So even though, yes, I've introduced a kind of a UV dependent, it's still ultimately all the patterns are based on the shape of the object. So this is an okay compromise. We do this at Pixar all the time. We always bake occlusion and curvature, or many times we do, and we always have that available, and we rebake it whenever we change the topology or shape of the model. Alright, this should be finishing up pretty soon. Watch those commands go. Alright, and we're done. So let's take a look to see at what we created, and here we go. That oxy, and we check it out. We got 2 of them, one for terrain, one for the rocks. So to look at a text file, I recommend just bringing up it and dragging it in right here. And check it out. You can kind of see this halo wherever the rock was intersecting the ground, and it's in that halo region that we want our dirt pattern to show up, and maybe also where we want to grow some vegetation with XGen. And let's take a look at the rocks. Kind of cool, you can see that atlas right there. Oh yes, look at that. That is a little too much occlusion. I don't know why this is the case, but it appears that at least in this version of RenderMan 21, using this new bake hider technology, displacement isn't handled correctly, and we have a lot of self-occlusion in here. I'm not sure if it's a trace bias issue or what, but one thing I recommend doing before you bake is to turn off your displacement. So I'm going to do that by going to this PXR displace node, which is the only one we have, and unchecking enabled. And then I am going to do a rebake. I'm curious. I have a feeling this will create a much cleaner signal. So, sorry guys, we're gonna have to wait and watch for another, another bake pass to go through. So while this is going, let's talk a little bit about what we're gonna do with XGen. So, often where we create this dirt layer tends to be at contact points between objects, and it helps seat one object on top of another, kind of blends the boundary, because in CG, when 2 objects meet each other, it often looks unnaturally clean. So this dirt layer based on occlusion and curvature is going to help seat one object on another, create that continuity. But even better than seating with color, creating a little bit of vegetation and moss, especially on terrain, really helps unify the environment. You take a look at a rock, in the woods, especially any area that gets rain, there's going to be moss that sort of connects the ground with the rock and so on. So this baked occlusion and curvature is useful not just for the dirt material, but also for where we grow vegetation. Now, at Pixar, we have our own system called Wonder Moss, as well as another system called MILOD, and a various sets of tools to create vegetation. But we're going to use XGen. XGen actually has its origins at Disney, and is now part of Maya. So, XGen's pretty professional stuff. And yeah, I'm looking forward to showing that to you guys. Alright, looks like our textures are baked again. Sorry to put you through that. Let's take a look. I'm curious if the rocks look cleaner now. Oh yeah. That looks a lot better. And we can compare that to there. So yeah, just for now, please turn off your displacement when you're baking. But once you're done baking, we can turn that right back on. Okay, so so yeah, to see the results, not very hard. You just go ahead and click render. Baking only kicks in when you click bake render. Every other render is going to be just normal. So let's see how much faster this is. Yep, that is going really quickly. Oh yeah, especially the refinement. Yeah, look at that go. So, all right, we're back in business. We can start doing live renders again and start doing some shading. Um, all right, so I'm going to go ahead and cancel that and let us kick off a live render and maybe refine this a little bit. So one of the things I'm noticing is this is a little low contrast, the dirt. So I'm going to try to tighten it up a little for the rocks and the ground. And I might want to do each one separately, kind of tune it. So we can do that by kicking off an IPR render. And let's start dropping in nodes. Let's see, where did that... Hello, IPR render. Try that again. Ah, second time's a charm. All right. So what I'm gonna do is create a PXR threshold node. And I am also going to probably want to mix the facing ratio and the dirt differently for the ground as well as the rocks. So I'm going to go ahead and create another PXR mix node, and basically a duplicate of the one up there. And I'm going to connect result RGB there, and then result RGB second input. And for now, I'm actually going to set that mix all the way to 1, so we're only seeing occlusion. And let's go ahead and I'm just going to not use the threshold for now and just connect it directly to the layer mask of the ground. So this is the equivalent of just looking at the baked occlusion and curvature for the ground. Oh, sorry, wrong thing right there. That did absolutely nothing. This is the connection we want to make. Oh man, I need a bigger monitor. Results, RGB. Let's get that guy. No? Hello? Oh, RGBR. This is, I'm just trying to connect the color data type to a float data type. There we go. So now it's just occlusion and curvature. And yeah, that's looking pretty wishy-washy. We want to make that a lot stronger before mixing in our facing ratio. So I'm going to go ahead and put this PXR threshold after the baked texture. And right before our mix. Cool. All right, that already got a lot higher contrast. What the threshold is doing is basically saying everything below this threshold is black, everything above it is white. So if we lower that, we should see that occlusion and curvature start to creep out from underneath the rocks. Cool. All right, so that's that's pretty extreme, but that's kind of where we want to grow our grass. But I'm going to soften that by increasing the transition width, which essentially is a blur along the edge of that. I'm going to really crank the transition width. Alright, so I made that at max. I'm going to maybe raise the threshold a little bit. Keep it close to the rocks. So cool. So that's going to sort of be the, an extreme amount of dirt and such there. But that should be pretty good. But what I'm going to do, though, to take that down is going to take that mix maybe to a 0.5 so that we only take half of that and we mix it with a little bit of the facing ratio. So now it's just, getting a little bit around the edge. I actually might want to take that mix back to 6.7. And this is what I mean by having a live render is pretty useful. It's kind of miserable to have to stop and hit render each time, so it's really worth baking those patterns to be able to tune it in like that. And maybe 0.6. I keep on. being wishy-washy about that. All right, that looks like it's pretty good for the ground. And actually for the rocks, I'm pretty happy with the way it's looking. So, yeah, again, if we compare that to what it used to look like, I think that looks a lot better. Cool. So at this point, let's go ahead and start doing XGen and growing some grass. So I'm going to stop that live render. Hello. So escape maybe? Uh-oh, it's not stopping. Interesting. Let's, oh, it did stop. It was just a little non-responsive. Okay, let's go ahead and get back to Maya. Wow, it does not want to minimize. Let's hit escape a few times. We are out of control here. I should do some editing on this video. Alright, so if you ever lose control like this, one thing I like to do is go to the task manager. Just sort of like kicks Maya and RenderMan and say, hey, wake up, you know, there's other processes on this machine. We can close that, and now maybe we'll have mouse response. Okay, when in doubt, Control-Alt-Delete. That can get you out of some kind of weird UI loop. So, alright, now let's do the XGen stuff. So, I'm going to minimize it for now. And also, I'm going to name this. I'm going to call this Awesome Shaders, because we might end up changing a little bit about these networks, and I want to have a view of it that we can keep. So I'm going to make that a little larger. So to grow grass, what I recommend doing is select the ground, go to XGen, open your XGen window, and go to Create New Description. Now, there's a few kind of XGen descriptions. For those that are doing grooming, say hair and a character, groomable splines are what you want to do. But for this, I want to be procedural. I essentially want to use noise and expressions and maybe some painted maps. So I'm just going to go to regular splines. And there's other cool things, custom geometry if you want to like instance little rocks. But for now, you know, let's just do splines. I'm going to call this grass demo C, because it seems like we're on version C of this. I'm going to go create, and we should hopefully see some little bits of curves sticking out of our ground pretty soon. Alright, and if we deselect, there we go. So we kind of have grass everywhere and it's not green. So let's go ahead and start making this look more like grass and see if we can keep it just around the rocks. So, to change the color, there's primitive color right here. We can just go ahead and select green, maybe not quite so neon, and that should hopefully turn our grass green. And you know that the updates are not that great, not that fast. We can lower the density if we want to work a little quicker, but since I know what I'm doing, I'm just going to leave it like this. Alright, now let's also make it a little longer so that we can really see what's going on here. So most of the options are under primitives right here. I'm just going to go and make it length 5 right now. Cool. Alright, that's looking pretty good. Now it's very important when you're doing grass to, to sort of vary the parameters or any vegetation, to vary them based on some noise. So just like earlier, like noise is just like that fractal. You want to get that frequency to be just right to give some variation. So to kind of know what frequency I should be using in XGen, I usually want to experiment on color. So one of the things you can do is open up the expression editor. Now, XGen is from Disney, and Disney Animation sort of philosophically does not like node graphs. They rather prefer sort of painting-based approaches in context as well as expressions using SC expressions. And XGen is very much expression based. So what we were doing with nodes earlier with shading, we're just going to do the same thing but with expressions. It's just two different ways to look at it. Some people like one, some like the other. But basically I want to control the color here by noise. So it looks like, let's just use noise to vary the green channel. And I'm going to use what's called an FBM. You can see it completes. An FBM is a fractional Brownian motion. It's essentially what the PXR fractal is. Now, what we're going to do is pass it pref, which is the basically it's the point of the object before any deformation is applied. So if you're doing deformation, the grass would stick. So I always recommend using pref and not using just p. And yeah, let's see what happens if we just do FBM of pref. Now this is pretty much the equivalent of doing a PXR fractal with a world space manifold and 1 as your frequency. You can see I see little black, here, but it basically just looks green. The frequency is way too high. I don't see any clear noise pattern. So we're going to go to that pref, and you see noise up there, but clearly that's not the same scale as the scene. I'm going to multiply it by 0.01, but so basically 1/10 the frequency. So we should have, the blob should be 10 times as large, and hopefully we should see some patterning. Ah, there we go. Check it out. That's pretty good looking. I might lower it just a little bit more, 0.05. And tell you the truth, whatever we came up with that fractal earlier for the ground is probably pretty good as well for here. And there we go. I think that's looking nice. So now that we know that is a good frequency of noise to use, we're going to plug that into lots of expressions. In fact, let's go ahead and maybe vary the length a little by the noise. But I know what you're saying. Before we do that, I promised you guys we would get the texture, we would get the grass growing mostly just around the rocks. So before we start varying up each parameter, let's go ahead and do that. Now the way we do that is a little bit weird. It involves going into paint mode, painting a parameter like density, and then switching underneath the hood the texture that was painted out with the texture that we baked, and then tricking essentially XGen into using our baked texture rather than the one we paint. So stay with me, it's weird. So what I'm going to do is we ultimately want to control density with the texture. So we're going to start by painting density. Now you got to watch out because you can only paint with certain materials bound. It doesn't really recognize Pixar materials. So we're going to have to take our ground right there and create a Lambert. Boo. Well, hey, you got to just do it. Where'd that Lambert go? There's our Lambert. And with the ground selected, right click and assign it. So now with that Lambert on the object, we can go and drop down here and say create map. I'm going to call, you got to give the map a name. I'm going to call this density map demo C. And I actually want to start off with black. I want it doesn't really matter, but just to make this obvious, I'm going to start off with 0 density and just paint a little bit of density. Map resolution has to do with the ptext file that's going to be created by XGen. So even though we're actually going to be painting in UV space underneath the hood, XGen is going to create ptext or per face texture. This is again sort of shows the Disney heritage of this tool. They love ptext, and there are some very good things about ptext that I won't get into right now, but that's sort of what this is talking. How many texels per face, I believe. So let's go ahead and create that, and let us go and start painting. So looks like I'm going to do a flood fill of black. I thought that's how I was going to start. And hopefully that will make all the grass go away, I think. Oh well, I'm not sure why that's the case. So I'm instead going to just make my radius really big, make my color white, and paint and see what happens. Nothing's happening. Maybe let's paint black. Oh, I think maybe I have to click that paint button. There we go. Okay. So now it is letting us paint. Sorry. So yeah, I'm gonna go ahead and well, that should be pretty clear what's happening. So we should get a bunch of grass here once we save this out by clicking that save button. So that should turn this UV texture, resample it into a PTEX, and when that's done, nice. We only have grass where where we painted. Ah, darn it! I moved my camera. I want to get back to my old camera. There we go. Cool. So there we go. So we have some grass right there. So that's great, but we want to, instead of using that density map, use the one that we baked. So check it out. To do that, we need to actually, let's go ahead and select that and find, graph it and find, there we go. We have this right here. If we go to, sorry, the attribute editor, that has our painted texture right there, as you can see. If we take this node that was connected, this little texture node that we were painting into that was connected to the ground, and then browse for our baked occlusion, we should be able to do the right thing. Now, one thing that occurs that you'll run into is we baked into text format, but Maya's node expects something like a TIFF or a JPEG. So to reconcile that, what I recommend doing is, here we go. There's our occlusion c.text. Just in it, I think you just right click and file, export file, and I'm just gonna export it to a JPEG. Really classy. And yeah, so that's what we're going to use. So you got to use it to do a little bit of a file conversion right there. But now that we've done that, we should be able to, under RenderMan, find occlusion C JPEG. There we go. So now that is there. So now that we have that loaded into this node right here, we should be able to, go back to our XGen viewer. And hit save, and that should resample it into PTEX, and hopefully the grass will only grow in greater density around the rocks. And let's see what happens. Whoa, it worked. Check it out. More grass around where the rocks are. Note that I think we're getting a little too much grass in other areas as well, so you might want to clamp that a little, and that's again one of the cool things about expressions. So if we click here, it's kind of interesting that, again, like I would normally do this in a node graph with PXR threshold, but for now we're just going to kind of do this, just using expressions. So I'm going to do $A. I only want grass to grow maybe where the density is, greater than like some value like 0.5 or something. So I'm going to say A equals A times A greater than, I don't know, 0.25. So remember, we set A to that density map right there. Now we're setting it to itself times this, this Boolean right here. Are you greater than 0.25? So that maybe should mask out density. Oh, and it looks like I created a syntax error. Oh, don't forget a semicolon. Very important in this XGen expression language here. And let's see what kind of grass we get. What? Is that still a syntax error? Oh, semicolon, not full colon. Man, you got such a great demo artist today. All right, there we go. Check it out. Grass is just growing around the edge of the rocks. All right, that's a little too much. We could instead do 0.5. And then maybe we'll just go out a little further. All right, that's looking pretty good, actually. Maybe 0.25. Beautiful. Okay. I think that's looking pretty good. Another thing we should do is right now the grass is not tapering. It's just kind of like a thin ribbon. So in the width ramp, I would make sure to add a knot and drag it down to 0 at some point, and that will taper the width of the curve. Cool. You know, we might need to increase density as we did that, but trust me, this will look a little better. All right, now let's talk about length. I'd actually probably like to use the density map as a length map as well. So I'm going to go ahead and copy that. And I'm going to go to length. Right now it's 5. Instead, I'm going to set it to that density and maybe multiply it by 15 or something like that. And see what I get. Similarly, yeah, a little taller around. Oh, it looks like it's actually growing through the rock. So we got to be careful. Where the density is, where the occlusion is highest, they're actually probably underneath the rock. So we actually probably want to make the length lower at the highest density, but then higher at the lower densities. So actually, I might do something crazy like 1 minus 1.0 minus density, so that we actually do the opposite. So we don't have it. Sorry, 1.0 minus density times 15. I don't know if this is really going to work, but hopefully then it won't go through the rock. Cool, that's looking a lot better. Maybe it's getting a little too tall and wispy out there, so I actually might lower it a little where it's getting kind of far. So I also might want to say, yeah, I might want to do that kind of thing I did earlier where $A equals $A times itself, or yeah, basically multiply it by the map again, and that will sort of make it smaller as it gets further. So let's give that a go. Hopefully that'll shorten it a little. Oh, that's too much. Yeah, let's not do that. I kind of like what it was before that. So let's just keep it simple. Sort of like the tall grass out there. Cool. All right. Another thing we might want to do is we have a lot of grass growing on these kind of vertical faces right there. We kind of only want to have grass growing on level areas. If the ground is too steep, you know, it won't take hold. It just looks kind of unnatural to have grass around there. So another thing I might do with density is basically multiply the density by the dot product of world up and the surface normal. And you can do that. Let's see if I remember this expression. I say A equals A times dot, which is basically what that PXR facing ratio node was that I was showing last lesson. That of nref, which is the undeformed normal on the object, and the vector 0, 1, 0. And if we do that, it should hopefully take away density on these vertical slopes. Oh, thought it would. Maybe we should do something where the dot product is greater than a certain value, so that we, you know, where it's low, we really make the density 0. So I'm going to say dot product is greater than 0.5. Make it really extreme. There we go. So now we cleared the grass on some of these vertical areas. In fact, that was so good, I might actually, it's actually, if we raise it a little bit more, it'll be a stricter rule. So 6.6. Cool. All right, that's looking kind of nice. We lawn mowed these sort of vertical areas. So it's really just growing where the ground is level now. All right, so I think we've kind of groomed enough. Now we have to render this. So let's go ahead and go to RenderMan and click render and see what happens. And I'm going to tell you offhand, it's not going to look great. because the color is not going to be right. You know, that primitive color that we set in this tab right here, that's only for preview. It actually has nothing to do with the real color in the scene. So I'll show you how to fix that. Alright, let's see what we get. So we should see some ugly gray straw growing out of the ground. But this should give us an idea if the density is at least in the ballpark. Oh, and also the ground is still a Lambert. So this is bad in a lot of dimensions, but you can see some little bit of grass growing there. So sorry about showing you that ugly render. So let's go ahead and reattach our original material. Oh man, it looks like we did this in... I should have created a new tab when doing that. So one way we can find our old material is if we graph at least the rocks, and then we look for that PXR dirt. This should be connected to do different things. So if we graph that, there we go. Here's our rock surface. We found it. Sorry, that was a bad thing. I should have created a new tab. All right, let's assign that material. And all right, also, so while we're at it, if we want to assign a shader with a color to the grass, what we can do is select that collection, the XGen collection, and I recommend creating a PXR Marshner hair. This is more for human hair, but it can really shade any curve. You've got a lot of options there. So let's go ahead and make the diffuse color green, as well as the transmission and secondary color. We want to leave the primary spec uncolored so that it doesn't look metallic. If you want, you can make the secondary spec a slightly different color than transmission, just to be fancy. See, it's more saturated when the light, well, it doesn't really make any sense. I'd probably do the opposite. I'd make the transmit a little more saturated. And also, there's no diffuse on it right now, so you can see right here, we're really just coloring the highlight. You know, grass, it's got a lot of scattering in it. You're going to want to mix some diffuse in. I'm sorry, I know that might not be physically correct, but nah, that looks pretty good. Cool. So we select the collection, right-click, and assign to material. Now if we render, the ground should have the right shader, and we should at least have green grass. Alright, moment of truth. What's going to happen? Will this work? So, assuming the grass is green, you might be wondering, wait a second. What if I want to use some kind of fractal pattern in XGen to control the color? There's a way to do that too, and I'll show that to you next. That being said, you could also use fractals in the in your shader network as well. You don't necessarily need to use the FBM. Cool. Well, how about that? Oh, it looks like somehow I attached the rock shader to the ground, but that actually looks kind of cool. I sort of like that better. Did I really attach that? I mean, that actually looks kind of nice. And you got some grass growing there. Isn't what I intended. Let me see what I actually did. Oh yes, I attached the rock. What I'm looking for is ground. This is what I meant. Well, let's see which one looks better. Man, I sort of like that. Alright, sorry. We got to actually maintain the selection. Assign the ground. Well, that's one of the nice things about it is we're storing a catalog here so we can decide which one we like better. And that's looking really cool. However, we need more grass. You know, that density is fine for preview, but for final render, we might want to create some more. Also, it's sticking straight up. We should really have it bend a little bit. So after this render, maybe let's bend the grass and then talk about how to actually pass a color pattern from XGen into your shader, if that's what you want. That's useful if you're doing things like literally like painting stripes on a tiger and you want to use the paint tools and have that get picked up by the hair you're growing on it. Okay, so as cool as this was, that is awesome looking. This is a little more what I was going for. I don't know, man. If I feel like we just tint that a different color, and that would look really good. Cool. So yeah, right now the curves are like just going straight out. It looks a little bit unnatural. Also, we might want to actually thicken them up a little, so I might want to increase their width. So let's go ahead and work on doing that. So if we select our collection and go back to the XGen view, so increasing the width is pretty easy. Right now the width is 0.1, it looks like. Let's just make it 0.25. And our grass will be a little thicker. And we definitely want to bend it. So for that, I want to control the tilt U and tilt V parameters. So I actually recommend using noise roughly at the same frequency that we did for the color. So I'm going to basically do FBM of PREF, I think it was time 0.05. PREF times 0.05. And that's going to be between 0 and 1, which I think is a little high. I tend to just multiply this by 0.2 or something like that. And hopefully, we don't want to bend it so much that it's going underground. And let's see what happens. Cool. So we tilted it in one axis. So one thing I like to do is just copy that from U into V as well. Now, one of the things that's a little bit problematic is that essentially bends it diagonally in UV space, whereas really you want independent U and V. I think these are actually going to become the same value, so I like to offset the FBM. So I'm going to do PREF, and I'm going to add a constant value to basically just essentially change the seed of the fractal to make sure that we're getting a different fractal. So I'm going to basically add, I'm just going to do, it's a 3 vector, so I'm just going to do 0, 0, 0, 0, 100. That should hopefully decorrelate the U and V tilts. Hard to tell, but I think it's working. Oh, I think it says there's a syntax error. Oh. Yeah. Got an extra A there. So actually, it wasn't doing anything before. There we go. Cool. So we've thickened it. We've added some tilts. Let's see what our next render looks like. The grass also might be getting a little far from the rocks, but we'll see what happens. Wait for it. So note there's a little more startup cost when we're doing grass. You know, the more complex the scene, the larger it is to build your trace acceleration structure. You know, the whole pipeline crawls a little as you start adding, you know, vegetation. That being said, it's really important to have this kind of detail to make your scene look believable. All right, that's looking a little bit nicer. Getting some grass growing around the rocks. We're definitely getting some thickness. You can see how it's sort of blending to the ground where we added that dirt. I actually might want to desaturate the dirt pattern on the ground a little, but yeah, that's looking pretty cool. So this is pretty much where I want to leave the look, but I did promise you guys to show you how to get color out of XGen and into that shader. So let's go ahead and talk about how to do that. So I'm gonna really make this obvious by going to our preview node, going to our primitive color, and rather than just having, you know, green, I'm also going to mix in, let's see, RGB, maybe a little bit of red to sort of brown up some of the grass. So I'm going to create an FBM for the red channel as well, but I definitely want more green than red. So I'm going to multiply this guy by maybe 0.25, and that should hopefully make some of the grass a little bit browner. Okay, yeah, that's looking pretty good. You can see you get a little bit of brown elements as well. Maybe a little higher. Actually, I think it went lower. All right, well, I don't want to noodle it, but basically we want to get this color into a primvar. So that, or basically we want to get into our RenderMan shader, and it's using something called a primvar. Primvar will just be a color that's actually stored on each curve that we can read in our shader. So I'm actually going to copy that primitive color, and then if you go to primitives, see where this setting is. Oh, sorry, rather output. So we got to change our renderer from Mental Ray to RenderMan. It works, you know, even without that, but once you start using primvars, this is important. So we change it to RenderMan, and then we create a custom color shader parameter. And I'm going to call this grass color. We add that custom shader parameter, and where did that go? Oh, here we go, color grass color. And then in the expression, we can paste the very same thing we used for the primitive color. Cool. And now you don't see any difference here. This is for render only, but if we want to connect that to our hair shader, we can create a PXR primvar node, and we can connect that. Oh, sorry, we gotta set a name. So it's gotta be the same thing here, grass color. So if you select that, close XGen. All right, we want this variable color, grass color. And then let's connect that result RGB to the diffuse color. And maybe, yeah, I don't want to, you know, we could do some saturate and desaturate of the other ones, but yeah, for now, let's just connect it to diffuse color and just make sure something looks different. So let's go ahead and then just render that and make sure that something happened. Again, this is a little more important when you're like grooming like fur on a character than it is for grass. Like with terrain, I'd probably do the procedural color just in a node network. But yeah, passing primvars from XGen to your hair shader is a totally cool way to drive the pattern as well. And let's see what we get. Startup is always so much slower once you have XGen, but okay, I'm seeing a little more reddish hues in the grass. Again, we can toggle between the last two renders, and yeah, check it out, different colors. Let's let that converge a little bit more so that we can really compare apples to apples. But yeah, we got some red color now in our grass, and that's being passed through as a primvar. But to tell you the truth, I really liked that rock shader. So before ending the demo, I'm going to very quickly select the ground, select the rock shader, and I'm going to let that be the last image because that just looks so cool. So that pretty much concludes this demo on shading some terrain. Just to review, our shaders as well as the vegetation are entirely based on the shape of the objects. No painted UV maps were used. The only UV textures used were generated using PXR dirt, which is based on the shape of the object, occlusion and curvature. So in general, this is all based on the shape of the object. This is a great way to shade terrain and environments, and even characters sometimes, or at least elements of characters, because it's very easy to transfer these materials and looks from one object to another. The only thing you need to do is make sure the scale of the patterns are right for the scale of your scene. Once you get that, these are really easy looks to transfer. Now, I did not cover things like doing projections to add graphic detail, but that's, I feel, is covered. We can cover in a different talk and is covered in other areas as well. So how about that? That is looking pretty fun. So thank you for watching. Let's hope this video really recorded. And yeah, let me know if you have any questions. Thanks.